Hello everyone. Today we will be learning about scalar and vector quantities, two very important ideas in physics that help us describe motion, distance, displacement, speed and velocity. Physical quantities can be classified into two types: scalars and vectors. Scalars are described only by magnitude, whereas vectors need both magnitude and direction. A scalar quantity is described by its magnitude only. Examples are distance, speed, mass, length, area. Notice that for all these, direction does not matter. For example, if I say the mass of an object is 2 kg, there is no direction attached to it. A vector quantity requires both magnitude and direction. Is distance a vector quantity? No. Displacement is a vector quantity. Is mass a vector quantity? No, it's a scalar quantity. Weight, on the other hand, is a vector quantity. Is speed a vector quantity? No, it's a scalar quantity. Velocity, on the other hand, is a vector quantity. If I say the car is moving at 60 km per hour towards the east, that is a vector because direction is included. Let's start with distance. Distance is the total length of the actual path traveled. For example, if a person travels from his home to school through these points A to B, B to C, and then C to D, this is the path. So he is covering 5 kilometers, then 2 and then 4. So 5 plus 2 plus 4 kilometers is equal to 11 kilometers. Distance is always positive and it does not depend on direction. Now displacement. It's the shortest straight line distance from the initial to the final position. Using the same example, a person's displacement would be the straight line from A to D. So, displacement is the shortest distance from the initial to final position in a specific direction. So, even though the person traveled 11 kilometers, the displacement is not 11 kilometers. It is less than the distance in this case. So, distance and displacement can be different. Here is a clear comparison. Distance is the total length of the actual path, whereas displacement is the shortest straight line distance with direction. Distance is a scalar, whereas displacement is a vector. Distance has only magnitude, whereas displacement has magnitude and direction. SI unit for both is meter. So, distance is the total length of the actual path and displacement is the shortest straight line distance with direction. Let's say that a person travels around a closed path and returns to the starting point, which is A. So starts from A and returns to A. So the total distance here is the sum of the entire path, which is greater than 0. It is 5 kilometer plus 5 kilometer plus 5 plus 5, which is equal to 20 kilometers. But the displacement would be 0 because the start and end point are the same. He is returning to point A. So the displacement is 0 kilometers. Here you can clearly see the difference between distance and displacement. The actual path is taken by the blue ball, whereas the red ball is taking the shortest path. Again, you can see the difference between distance and displacement. The actual path from A to C is A to B and then from B to C. So the blue ball is taking that path A to B and B to C. The total distance traveled is 4 plus 3, which is 7 meters. And the displacement, which is the shortest distance between the initial point and the final point A to C, is just 5 meters. Can displacement be 0? Yes. If you start and finish at the same point, your displacement is 0 even though distance is not. For example, jogging around a park and returning to the start gives you displacement equal to 0. Can displacement be negative? Yes. Displacement can be negative. Suppose you define the forward direction as positive. If you move backward relative to the chosen reference, displacement becomes negative. But remember, distance is always positive. So we are taking the path towards the right as positive and the path towards the left of 0 as negative. So displacement can be negative, but distance is always positive. Velocity is the displacement of an object in unit time. Velocity is equal to displacement divided by time. A to B is 3 meters and B to C is 4 meters. So the hypotenuse will be 5 meters. This is the displacement. So let's say the displacement of the object is 5 meters and the time taken is 5 seconds. So velocity is equal to 5 meters divided by 5 seconds, which gives the velocity equal to 1 meter per second. SI unit is meter per second. Here is the difference. Speed is equal to distance divided by time. Velocity is equal to displacement divided by time. Speed is a scalar quantity. Only magnitude is required to specify speed, whereas vector is a vector quantity. It requires both magnitude and direction. SI unit is meter per second for speed as well as velocity. Can speed be negative? No, speed cannot be negative, but velocity can become negative. So what did we learn in this session? Scalar quantities have only magnitude, while vector quantities have both magnitude and direction. Distance is a scalar and measures the total path covered regardless of direction. Displacement is a vector and measures the shortest straight line distance from initial to the final position. Speed is a scalar, but velocity is a vector because it involves direction as well as magnitude. Displacement and velocity can be 0 or negative, but distance and speed are always positive.